Next topic is CR equation in polar form. When the complex function is given in polar form, that is Rn in r and theta, we can't use CR equation which are in the Cartesian form. Till now we discussed in the Cartesian form, right? We can't use that equations in polar form. So we have another pair of CR equations which are in the polar form. Okay. If any equation written in r and theta instead of x and y, those are known as polar equations. If the equation is represented in x and y, that is Cartesian equation, and when the equation is represented in r and theta, that is called as polar equation. Okay, let us see what are the CR equations for polar form. Okay, so we know that z equals to x plus iy, which is in the Cartesian form, and polar form, in polar form z can be written as r cos theta plus I into r sin theta, where from these two we can take r as common, right? Z equals to r into cos theta plus I sin theta, but this is in the form of power series. What we can write? Z equals to r into e power I theta by power series we can write. Okay, so this is a polar form equation. Now from these we need to extract the CR equations. How can we extract? Let us see. We know f of z equals to u plus iv, whether it is in Cartesian form or it is in polar form. You can equate the given equation with u plus iv. Okay, now u plus iv can be written as, what is z here? This one. So f of r into e power I theta we can write. Clear? So this can be the first equation. Now we have to differentiate this equation partially with respect to r. Here r and theta are there, no? So we need to differentiate partially with respect to r and theta. First of all, we'll do with r. When you are differentiating with respect to r, the left side term will be dou u by dou r. Okay, plus I into dou v by dou r equals to, right side also you need to differentiate. So first f dash of r into e power I theta, where internally we have the function, so we are differentiating it again, into dou by dou r of r into e power I theta. Clear? Now this can be simplified as f dash of r into e power I theta into dou by dou r of this function. Here when you are differentiating with respect to r, e power I theta is constant, only r will be the variable. Dou by dou r of r will be 1, so we'll get directly e power I theta. Fine. So this is dou u by dou r plus I into dou v by dou r. This is a second equation. So we have done with differentiating with respect to r. Now differentiate the equation 1 with respect to theta. Same as the above, we get dou u by dou theta plus I into dou v by dou theta equals to f dash of r into e power I theta into again dou by dou theta of r into e power I theta. Okay, again dou u by dou theta plus I into dou v by dou theta equals to f dash of r into e power I theta into, here r is constant, this term will be the variable, so r as it is we are writing, e power I theta, differentiation is e power I theta, but in the place of x we have I into theta, so into I. So what will be the final equation? I into f dash of r e power I theta into r e power I theta. Okay, this is the third equation. Okay, so from 2 and 3 what we can write here, in the place of f dash of r into e power I theta into e power I theta, here also same, f dash of r into e power I theta into e power I theta. The remaining terms are I into r. So I am writing, in the place of this term we can replace the second equation, right? So I r into, this is dou u by dou r plus I into dou v by dou r. Is this clear? In the place of f dash of r into e power I theta into e power I theta, in the place of this one we are writing dou u by dou r plus I into dou v by dou r. Okay, now here we need to separate the terms, that is like a CR equation we need to extract from this equation. See that? So by multiplying internally we'll get dou u by dou theta plus I into dou v by dou theta equals to IR dou u by dou r plus I into I is I square value is minus 1, right? So it will be the minus r into dou v by dou r. So separate this real term and imaginary term. So finally, by comparing the real and imaginary terms on the both sides, we will get dou u by dou r equals to 1 by r into dou v by dou theta, dou v by dou r equals to minus 1 by r into dou u by dou theta. These are the CR equations in polar form. Okay, here a problem, that is find p such that function f of z equals to r square cos 2 theta plus I into r square sin p theta is analytic. In the problem the given function which is in polar form, because it is in r and theta, so it is in polar form, it is analytic such that we need to find p value. Okay, so if a function is analytic, said to be analytic, then it should satisfy the CR equations. By using the CR equations we need to solve this problem. So always f of z equals to u plus iv, that we know from beginning of the chapter. Now the given function is f of z equals to r square cos square 2 theta, r square cos 2 theta and r square sin 2 theta, only sin and cos. Okay, so now when compare with the u and f of z, we can write it as u equals to r square cos 2 theta and v equals to r square sin p theta. We need to find the p value. So by CR equations, what we can write? CR equations in polar form. What are the CR equations? We already discussed dou u by dou r equals to 1 by r into dou v by dou theta, and another one is dou v by dou r equals to minus 1 by r into dou u by dou theta. Okay, these two are the CR equations in polar form. Okay, here the function is already given that it is a analytic, so we can write directly the equations. There is no need of proving any CR equations. Okay, by substituting in this we need not to prove it. Directly we'll go through the finding of p value. Okay, now dou u by you can take any one of this one. So we need to find the v value. So directly I am taking the second equation. There is no need of satisfying the CR equation. So I am taking directly second equation, that is dou v by dou r equals to minus 1 by r into dou u by dou theta. Okay. Now how can we find dou u by dou theta? What is the value of u here? Here value of u is this one. So we can write dou v by dou r equals to minus 1 by r into dou by dou theta of r square cos 2 theta. Left side also we have to write it, right? So dou by dou r of r square sin p theta equals to minus 1 by r into, we are derivating with respect to theta, so r square is constant, in cos 2 theta differentiation is minus sin 2 theta, again here internal differentiation into 2, the left side with respect to r, right? So we have this one is constant, this one we have to differentiate, that is 2r sin p theta equals to minus into minus plus 1r will get cancelled, 2 we are taking before, that is 2r into sin 2 theta. Okay, when you compare these two, what you are observing here, 2r will get cancelled, the remaining is sin p theta equals to sin 2 theta. So from these two what we can write, therefore p is equals to 2. So this is a final. By comparing these two we can write p equals to 2, so that is a final one. Okay, we find the p value.